Isang magandang buhay para sa ating lahat. So now, we are here to discuss for the compression members. So, for building columns, we have the W shape having the nominal depth of 350. Karamihan, yun ang kinukuha natin. So, we have here less or less are commonly used. Yan ang madalas kasi ginagamit. So, this section being rather square in shape are more efficient than other carrying compressive loads. So deeper sections are more efficient as beams. So we have build-up sections are needed in large structure for very heavy loads that cannot be supported by individuals. Rolled shapes for bracing and compression members in light trusses. So a pair of angles are usually unequal with long leads back-to-back ang ginagamit, so are used or with or without the gasket plates. So structural tees may also be used as top cords members for welded roots to trusses. So structural members subjected to axial compressive loads are often called by names. We have to identify their functions, or the best known are columns, so the main vertical compression members in a building frame. So other common compression members include cords and trusses bracing members in frames. So according to Euler's column buckling theory, we have his analysis. Leonard Euler, 1757. So his analysis is based on the differential equation of the elastic curves. So however, specific factors of safety and slenderness ratio limitations are applied from purely theoretical concepts. So we have the column. When column is loaded to the buckling loads or Euler loads, a column will fly by sudden buckling or bending. So if the column is hinged at both ends, Euler critical load is given. So we have here this formula. So ito yung buckling load. Ayan. So we have the length. For the buckling loads, ang sabi niya, the load are at which a perfectly straight members under compression assumes a deflected position. So we have the P equals pi squared EI over L squared. Okay, so for the critical stress, we have FP is equal to PE over A. So we have the formula for the Euler's formula. So we have here, so kinuha natin, binaba natin I over A kasi ang alam natin na I over A is square root R is equal to square root of I over A, or squared natin to get for the IA. So otherwise, pwede natin gamitin yung, we have here the pi squared E over L over R squared. We have the slender ratio. So the ratio of the effective length of the column to the radius of gyration of the column, both with respect to the same axis of bending. So this equation shows that the buckling is not a function of material strength, rather it is a function of the ratio L over R, known as the slenderness ratio. As the slenderness ratio increases, the buckling stress decreases. Now, meaning that as the column becomes longer and more slender, so the load that causes buckling becomes smaller. So, yun ang mga tatandaan natin yan. So, real columns do not have pin-connected ends. So, the restraint placed on the columns ends greatly affect its stability. So, to counter these effects of an effective length, which is K, is used to modify the unbraced length. So the product KL is called the effective length of the column. So this length approximates the length over which the column actually buckles, and this may be the shorter or longer than the actual unbraced length. So we have ito yung mga ginagamit natin. So according sa code yan, ha, yung mga yan. So usually 0.65, pero kadalasan 1 ang ginagamit. Value ng K yan. Yan, yung mga yan. So yan ang tatandaan natin. Okay, so we have here the formula F is equal to pi squared A over KL over R squared. So we have here a problem. So we have a wide flange of 5 meters. We have to convert it to millimeter para medyo okay tayo sa units. So we have the cross section, modulus of elasticity, radius along the x and y. So we have to determine the critical load of the column. Okay, so we have the formula P Fe over A, Fe multiplied by A. So we have Fe. So we have to substitute within the value. So we have here. So hence both ends, we are going to use the value of K. What is 1? That is 1. 5,000 yon kasi nga this is 5 meters. Convert to millimeters. So we have 100 KL over R. Okay, so substitute na natin yan. So, itong E na to nanggaling to sa modulus of elasticity. Ayan. So, we have here value of 197.4 megapascal. So, substitute na natin dito. So, we have area of 8,000. So, we have here PE natin o yung load natin na PE. That is 1,579.2 kilonewton. The tendency of a slenderness ratio, which is defined as the ratio of the length of the members to its least radius of gyration. So the greater the slenderness ratio, the smaller will be the capacity of the such column. So steel columns are usually subdivided into two groups. We have long and the intermediate columns depending on their slenderness ratio. For the intermediate column, so some of the fibers will yield stress, and members will fail combination of crushing and buckling, and their behavior is said to be elastic. Yan, tatandaan nyo dyan for the intermediate columns. For the long columns, the axial buckling stress usually remains below for a proportional limit and usually will buckle elastically. So long columns usually fail to buckling or excessive lateral bending. See, the longer the column is, the greater its tendency to buckle, and the smaller load it will support. So these are the formula. So we have here slenderness ratio. Yan. Yan mga yan. Along the x, along the y. So we have to use this one. So pwede natin gamitin. Depende kung anong gagamitin natin. Okay, so we have the critical ratio or the CC. So critical slenderness ratio corresponds to the upper limit of the elastic buckling failure, which is defined by an average column stress equal to 0.5 Fy and Fe. So we have this critical slenderness ratio is square root of 2 pi squared E over Fy. So we have the minors, axing, buckling, and bracing. So we have to check for this one. Ayan, ito yung without axing bracing. Ito yung meron. Ayan. Verify yan. So using the R minimum to get the KL over R maximum. Okay, for the limiting slenderness ratio, KL over R for members whose design is based on compressive force, preferable shall not exceed to 200. Actually, dapat hindi sumasobra. Yun yung dapat. For members whose design is based on tensile force, the limit of the slenderness ratio L over R probably should not exceed. So, ito yun, di ba? Remember, ito yung ating Euler's curve. Yan. Yan. Kasi actually, ito yung proportion ng mga kumbaga 200 in proportion limit. Kasi pag medyo yan sumusobra na yan, magkukatay sa yield point natin na yan. Di ba? Okay, so we have the NSCP. So for intermediate columns, KL over R is less than or equal to CC. This formula are going to use. We have the value for the FA, and then we have to solve for the FS. So uunahin muna natin solve yung FS before FA kasi we have to get for this value before to substitute here. Okay? And then if ever na KL over R ang malaki compared to si critical low, critical slenderness ratio, so we are going to use for this one. So makikita mo naman dyan. Ang gagamitin ng KL over R ay yung larger value, ha? Tandaan nyo. Compared to this one. Pagka dalawa, yung mas malaking gagamitin natin. Okay. Aha. So here, so we have the formula, we have the value for the modulus elasticity, yield strength, and then moment of inertia, and then we have the length, and then the area. Naka in terms of meter ang ating length, so we have to convert to millimeter. We have to determine the allowable compressive stress if the column is fixed at both ends. Okay, ayan. We have to get for the critical slender ratio. We have the getting that we can get the critical slender ratio to 140.496, and then for the range of R, substitute the value. So we have 68165. So makukuha natin KL over R, that's 142.02. So lumilitaw na ang mas malaki ay yung KL over R. So I used 0.65 for the recommended value for a fixed point, both ends. So doon sa code natin kanina na pinakita. Okay, so we have here, solve for the FA. So makukuha natin ng FA. So nakita nyo, ang ginamit natin 142, di ba? For the KL over R. So 51.06 megapascal. Yan ang gagamitin natin. Okay, next. So we have here, so check natin so yun ang pinaka most economical na gamitin. So we have the value of the area, ayan. So we have to get first the value of this critical slenderness ratio. Try natin ang B. So we have to get for the R minimum. For getting the R minimum, so KL over R, that is, ayan, 51.54. I use 1 for the value of the K. So, unbraced length. So, lumilitaw na mas malaki ang CC compared to KL over R. Yan. Critical. So, we have to get for the FS. Solving for the FS, saka pa natin gagamitin ang value na yon to solve for the FA. So, makukuha natin is 125.36.5. Tandaan mo yan, ha? Kasi susolve natin yung load na P. So, nakita natin na ang makukuha natin load ng P is 1461 kN. So, lumilitaw na mas mababa compared sa 18 na nandun. So, unsafe siya or inadequate. Hindi pwede. Unsafe siya. So, try natin ang A. So, solving for the minimum of A na R minimum. So, we have KL over R. So, still, mas malaki pa rin ang ating critical. So, get the FS. And then FA, 135. Substitute natin to get for the load P. So, lumilitaw na 1,815 kN. So, mas malaki to. So, lumilitaw na mas safe tong gamitin, di ba? Adequate, kumbaga. So, yan ang gagamitin natin. Yung section A. Okay, next. So, we have here dalawang column. Yan ay dalawang ating angle. An equal length. So, nagbinigay yung mga length niya. Ayan. Here, here, here. So, dalawa yan, ha? Ayan, o. Dalawa. Baka makalimutan nyo na dalawa yung gagamitin nyo. Okay. So, we have to get for the critical slender ratio, 126.16. Then, after that, we have to get for the KL over R. So, lumilitaw na mas malaki ang 187.5. That is KL over R. So, we can get the formula of FA. So, using the FA, we have 29 megapascal. Check natin. Sa doon naman sa isang sample natin. So, lumilitaw yung pa rin. So, 43. Check ulit natin. The other one. So, lumilitaw. Mas malaki yung CC. Yung critical. So, we have here 71.35 ang value ng FA natin. So, lumilitaw na ito ang dapat na gamitin kasi pinakamalaki ang kanyang compressive stress, di ba? Which is FA equals 71.35 megapascal. Okay, tapos, solving for the B, so we have the smallest allowable compressive stress. So, we have here, ayan, part ng B and C, ayan. So, kinuha natin, 133, yun yun, inadequate. Kasi nga, mababa. Okay, try natin isa. For here, so limit nila 201. So, mas economical na gamitin ang to angle natin na 150 by 90 by 10. Yan ang economical na gamitin. So, mache-check mo naman yan eh. Yan. Okay, next. For local backing, so we have here the values. Ayan, ang H natin. So, you have to look for this one also. Importante ito. Yan. Diba? So, local backing of the plate elements in a rolled shape or build-up compression members may occur before Euler backing. So, the ability of a plate sections to carry compression loads with or without buckling is determined by the width thickness ratio, B over T. Is a shape is selected from NSCP tables. So, yun na nga yun, mga table na yun. This ratio does not generally need to be evaluated. However, compressions members constructed from structural trees yun. Hindi yun trees. So, structural tubing and plates must be checked. Okay, so we have compressive members are divided into stiff elements and unstiff elements. So stiff elements are supported along two parallel edges. Example of are webs of W shapes and sides of box beams. Unstiff elements are supported along the only edge only. Example are flange shapes and legs angle. So we have here. So B over T, we have to get for the B over T is equal to H over square root of Fy according sa code. So makikita natin yan. And then D over T is equal to 22,750 over Fy. So makukuha din natin yan doon. So we have here. So mache-check natin yan. So we have the area ng flange. So yun, 30 by 20. So yung isa naman, we have to get for the area. Total, the area, we have 90,000. So we have 300 by 20. And then, 400 kasi to. Ayan, 400 yan. Ima-minus natin to. Ayan. Ayan, ima-minus natin yan. Dalawa na yan. Diba? Para makuha natin yung area. So we have 7,200. Saan natin yan? Diba? Bakit dalawa? Kasi nga, dalawa kasi to. Ayan. Ayan. Dalawa. Ayan o. Yung base natin. Ito yung width. Diba? Ay, nako. Yan. Dapat. Kailangan computing natin yun. Kasi nga, ito, dalawa yun. Diba? 6,000. Ayan. Kasi magtataka bakit 9,200 yan. Okay, next. So, we have here to solve for the IX. Diba? So, IX nito, IX niyan. So, we have here. So, makukuha mo is 511 million raised to millimeter to the fourth power. For the Rx, we have 163. So we have that one is 90 million. So for the Ry, 68. Ano isa natin nakuha kanina? Wala pa, no? So we have here, mas kasi nga, di ba, remember, sabi sa inyo, mas gagamitin yan. Ito, for the Ry, to get for the minimum. Okay, kasi nga, mas mataas to, 163. Eh, di ba, kailangan gamitin natin minimum. Yan, no? Sabi, unstiff is a projecting piece of with one or end free edge parallel to the direction of the compression force. So, the stiff elements, so we have projecting piece which is supported along two edges parallel to the direction of the compression force. So we have, since the section is not standard, we have to check the local backing. So makita natin dito, di ba? So we have here unstiff. So we have nagkuha natin B over T, that is 15. To check, we have here the value of the KC. Check natin yan, ha? Okay, so makikita mo dyan, it's 250 square root of KC. Value ng KC ay ito yun, yung mahaba na yan. Or else, pag nakita mo yung value ng H over T natin ay mas malaki yung 70, ang gagamitin natin ay 1. Diba? Nakita mo. Pero kung malas taas yung H over T, ito gagamitin natin. Yung KC na to. Yan. Okay, so 1 ang gagamitin natin. So we have here 15.88. So nakita mo yan, 15.88. So, value ng H over square root of Fy, we have 42.16. So, we have here local background will not occur, so we have no correction. Here. So, solve for the CC o critical slender. So, lumilitaw naman sa taas ang CC natin. So, we have here, solve for the FS first. So, solve natin the FS natin. So, we have 181. So, makukuha natin value ng FA is 125.8. That is sa load P. So, makukuha natin ay 2,415.36 kilonewton. Yan yung ating load of P. According to NSCP, the allowable stress or steep compression elements whose with thickness ratio exceeds the applicable non-compact limit shall be subject to a reduction factor of QS. Fy is not in megapascal. So, makikita natin dito, pag nag-satisfy yung ating itong tatlo na to, itong gagamitin ng reduction factor kasi you have to solve for the 200 over square root of Fy is less than or equal to B over T is less than or equal to 407 over square root of Fy. So, mache-check mo yan, ha? So, yan ang gagamitin natin. Pero kung mataas ang B over T mo, ito ang gagamitin natin reduction factor. Diba? Okay. Yan. For the angles or plates projecting the vent from columns or other compression members and projecting elements and compression flange of beams and girders. So, we have to check kung less than. Ito gagamitin natin. Diba? Madali lang. Pero kung ating greater than, yan ang gagamitin natin ng value ng reduction factor. Diba? Okay, for this, time or 2 of this, ganun pa rin. Ito ang gagamitin natin. You have to check according sa code yan. Yan ang mga gagamitin natin. Walang labis, walang kulang. Okay? So, according to NSCP, when the reed thickness of ratio of informally compressed elements except perforated cover plate so exceed the non-compact limit in reduced effective width, B shall be used in computing the design properties of the section containing the elements, except that B over T need to not taken as less than the applicable value given in this section. So the flange of square and rectangular section of uniform thickness. So we have here, sabihin natin, so you have to solve for this one. To check is dapat siya ay less than or equal to value of B. Ayan. Form the uniformly compressed elements. Itong gagamitin naman natin. Di ba? Ang daming formula, no? Okay. Next, for B, this is actual width of stick compression elements. For the T is the element thickness. The F is computed compressive stress, megapascal. Siyempre, if unstiff elements are included in the total cross-section, F for the stiff elements must be such that the maximum compressive stress in the unstiff elements does not exceed FA, QS, or QB, QS are as applicable. So we have here, for allowable stress for actually loaded compression members, unstiff or stiff elements shall not exceed the following. So, makikita mo naman yan, di ba? So, we have here, solving for the KL over C prime. So, we have the cross-section composed entirely unstiff. Q is equal to QS. And then, for cross-section composed entirely of stiff elements, Q is equal to QA. Cross-section composed of both stiff and unstiff elements, Q is equal to QS multiplied by QA. So Fs is 5 over 3 plus 3 KL over R. So we have minus yan. Ito mga gagamitin natin. So Q is equal to QA or QS. Diba? So you have to check for that. And then, if ever na mas malaki ang KL over R, yan ang gagamitin natin. So try natin. We have 2. Ito yan, yung leg na gagamitin natin. So we have here, so properties. So the area, 4,630. Hindi 4 point yan ha, 4,630. 4,630. Okay, so we have here, dalawa din. Solving for the Rx, that is 47.99. Sa RY natin, 35. So, ito minimum. So, ito ang gagamitin natin. So, yan na. Diba? 35 yan. Ayan. Ito kasi formula niyan, ha? Ay, pamunta ka kayo. Ayan. Okay. So, we have here our minimum. So, we have to check the local backing, the 19mm legs of the double angle member and stiff couple. Compression pala, I mean, elements. So, B over T is 9. So, we have used 200. So, makita natin is 12.70. So, lumilitaw na compact section kasi mas malaki ito compare dito. Diba? Mas malaki H natin. Okay, so ito na naman gagamitin natin. So, square root of this one. Ayan. So, we have to get for the critical and then, diba, the slenderness ratio. So, we have here, mas mataas ang critical. So, we have to get for the Fs. So, makuha natin Fs natin is 1.822. And then the Fy, Fa pala I mean. So, the Fa natin is 122.7 megapascal. So, we have load P. So, makuha natin load P is 568.101 kilonewton. So, yan yung ating gagawin. Okay, next. So, we have here, double na naman ang ating sample. Back to back. Ayan. Okay. Cassette plate. So, we have here, ayan, B over T. So, mali ito. Dapat pa ganyan yan. Less than 10.77. Less than 16.67. So, we have to check kung magkakaroon tayo. So, based doon sa ating nakita, ayan, nakita mo, sinod natin na itong 10.7 less than itong 16.67 and less than ng 21.91. So, ang gagamitin natin ng QS is this one. Diba? Nandun sa ating code. Okay, so masosolve natin ang QS natin ay 0.813. Solving for the QS, yan na, we have to get for the Q. Yan. So, QA natin is 1. So, makukuha natin ng Q natin ay 0.813. So, yung critical prime natin, solving for the critical prime, using the value of Q na 0.813. So, we have here the 118.64. Critical. Yan na. So, check natin kung ano mas malaki. So, lumilitaw na mas malaki pa rin ang critical. So, pag malaki ang critical, itong gagamitin natin. So, we have to get for the Fs. Solving for the Fs, na which is 1.88. Next, we have to get for the Fa. So, getting the Fa, using this one ha, kasi nasa sakod na natin. So, we have 115.77. So, we have to solve for the value of P. So, lumilitaw ng value ng P natin as 803.67 kilonewton. Diba? Madali lang. Basta kailangan alam mo lang yung gagawin mo na code. So, you have to check kung alin mas mataas o mas malaki. Okay, so for the column base plate, ito yung ating concrete, ito yung ating coal, ito yung bakal, ano. Ayan, lagyan na natin ng hinge. Ayan, both side. So, we have to get for the area, then area nito. So, ito yung nasa NSCP code, section 510.10.2 of NSCP. So, ito, dito mo rin makikita yan. So, we have here, yan. So, yung base natin, makikita mo yan. So, the formula. So, yan. Yung critical section for the moment. So, we have yung M na yun. Ayun din yung M. Ito yung N natin. Yung N na dalawa, ayan yun. So, makikita naman, ha? So, makikita mo naman kung ano yung mga yan. So, yung D or T are plate natin. So, we have here. Ayan. When X is the larger value of M. Ayan. So, we are going to use for this one. Solve for the T. The actual bearing pressure under the plate. Solve for the FP. Diba? So, try natin gamitin yan sa formula. Okay. So, we have here value of flange and then value of depth. Okay. Value of load natin, that is 3,600 kilonewton. We are solving for the FP. We have to get for the SC prime, 35%. So, we have 7.35 megapascal ng FC. Yan. So, next, we have the allowable bending strength on steel, 0.75% of the FY, which is 248 for this one. So, we have here 186 megapascal. So, after yan, 75%. So, we have to get here. And then, after that, yung area ng base plate natin, so, area is equal to P over FP. So, 3,600,000. Bakit ganon? Siyempre, look at here. This is 3,600 kilonewton. Naka in terms of meter yan. Millimeter po pinag-uusapan natin lagi. You have to convert it. Okay. So, nakuha ang area natin na required is 489,796 millimeter squared. So, N squared. Ito yung N na yun, ha? Diba? N squared. Yan. N squared. Multiply na. So, 489,796. Yan. So, yan. I-square mo yan, ha? Kaya naging 700 yun, ha? Baka magtaka ka bakit nag 700 yun. Kasi remember, you have to square the A, the area. Yan. Okay, for the M, which is the part of M here, yan. Yung M na yan, ito M na yun. So, we have here 142.425. For the N naman, ito naman yon, yung N na yon. Yung N na yon, dalawang N na yon, yun. So, we have 144.4. So, nakuha natin MN, yan, yung mga value. Okay, next. Actual bearings pressure, P. We have 3,600, 3,600,000. So, we have the value of FP, that's 7,347. Okay, we have to solve for the plate thickness. So, we have here, yeah, yung formula natin. So, we're getting for that, we have the value of T required. 49.71. Or more as 50. Diba? Millimeters. Therefore, we're going to use this one. Yan. We split natin. Okay guys, maraming salamat sa pakikinig sa aking lecture. I hope na mayroon kayong natutunan for this time. And then see you sa susunod nating lecture. Maraming salamat. Ciao!